children who live in the countryside go outside a lot, play outside, and so on, and they have much less allergy, much less asthma. Basically, the immune system learns what is important, which microbes it needs to react to with a strong response, or which microorganisms are harmless. And they just interact with us without doing us any harm. Being male is a risk factor. Men generally have more severe infections, and this was very clear with COVID. Men had significantly more severe infections than women during COVID. If we look at what happened with COVID from a scientific point of view, how incredibly fast vaccines were developed, antiviral drugs were created, and immunomodulatory medications were developed to rebalance the immune system. At an incredible speed, something unprecedented in 3 to 4 years. We had the cause of the disease, we had medicines to treat the disease, and we had vaccines to prevent the disease. This has never been achieved before in history.
Hello, dear friends. Our guest today is Mihai Netea, an infectious disease specialist at Radboud University Medical Center in the Netherlands. Welcome, Mihai.
Thank you.
Mihai Netea, our guest today, he is a doctor, university professor, and researcher. He studied at the University of Cluj, earned a PhD at Radboud University, and did postdoctoral research at the University of Colorado. He returned to Europe and since 2008 has been the head of the experimental biology section at the Department of Internal Medicine at the medical center affiliated with Radboud University. Thank you. He is, as he says, an infectious disease specialist, and maybe it's a good idea to ask him to tell us exactly what that means.
Don't forget to like, because it helps make the videos more visible on social networks like YouTube. Also, don't forget to leave a comment and share on other networks that are followed until the end.
Mihai, I believe we met 2 weeks ago in the Netherlands, and I asked you a general question then, which I'll repeat now. People might want to know why mice can be rejuvenated in the lab, as I read, but not humans.
That's a very good question. First of all, we need to ask ourselves whether the question is correct or if the answer suggested by the question is correct. Because in the question you say that people can't be rejuvenated. It depends on what we mean by that. Basically, I believe that people can do many things to slow down the aging process. Maybe it's not so much, let me say, spectacular, like in a science fiction movie or in a beautifully written book. But actually, there are many things we can do that can lead to stopping this process. So at the same time, we can significantly increase both the lifespan and the quality of life, even in humans, in my opinion. Of course, with mice, it's much easier. Why is that? For several reasons. First of all, the mouse has a much shorter lifespan, so it's much easier for us to do research and repeatedly try different pharmacological, genetic, nutritional, and other methods to increase lifespan. And we can do a study much more easily, which can show us at the same time that this intervention was successful. Let me give you an example. With mice, it's relatively easy to put 20 mice in one cage and 20 mice in another cage. And in the cage where we intervene pharmacologically with a certain diet or so on, to show that that cage of mice, after 2 years, doesn't live just 2 years, but lives 2.5 years, let's say, what is the average lifespan of a mouse? Doing the same in humans is much harder since such experiments aren't ethical. to force people to follow a certain diet or not. So from this point of view, it will be much harder to actually prove that that diet or that pharmacological intervention has the same effect. That doesn't mean it doesn't, actually. It could very well be that from an ethical point of view, we could do this experiment and practically imagine ourselves doing it. And let's say we wait 80 years, it could very well be that in the room, or let's say the house where I live. The people on whom we intervened with a certain diet, they don't live 80 years, but they live 90 years, let's say. So one of the biggest difficulties in getting a result with people, it doesn't necessarily come from the fact that that intervention doesn't work on people, but from proving that, in fact, it has an effect. To give a very simple example, we can do such an experiment very easily. We take a cage of mice, for example, in which we mimic a situation. We mimic an extremely polluted city, like our cities used to be, and unfortunately, like some cities still are in parts of the world. In a city like New Delhi or Mumbai in India, for example, there is extremely high pollution, just like European cities were 60, 70 years ago, or like cities in Romania were 30, 40 years ago. Well, if the mice are forced to live in that cage full of smoke, basically, since such studies are sometimes done, it's very easy to observe that that cage has a shorter survival rate. If we provide clean air, will the mice live longer? The same thing happens very simply with people, only you have to wait longer and conduct these much broader epidemiological studies. In the same, so we can demonstrate in humans that an intervention purifying the atmosphere, for example, positively impacts longevity. And at the same time, we can imagine that certain interventions we can do now with a certain healthy diet or with a certain pharmacological intervention, even that will probably be possible. In the future, it may have an effect. The hard part is proving that the effect actually happens, and the studies are much longer.
And if we're talking about questions that come up and need a scientific answer, there's this belief that exposure to microbes in childhood helps immunity. There is evidence.
There is very strong evidence for this hypothesis, actually. Okay, experimental models, even on animals. Animals that are not exposed during the initial period of life are much more susceptible to various infections, but also to autoimmune or allergic diseases. The same thing has been practically demonstrated in children as well. For example, children who live in the countryside, on a farm, and so on, or who spend a lot of time playing outside, and so on. They have much less allergy, they have much less asthma. Basically, the immune system learns what is important, which are the microbes it needs to react to with a strong response, or which are the microorganisms that are harmless, so to speak, and they just interact with us without doing us any harm. At the same time, it also learns to defend itself much more strongly against pathogenic microorganisms, meaning those that can cause serious infections. Definitely balanced exposure doesn't mean that any infection children get is a good thing, because there are also infections. Yes, it can be very good for those who survive, but any serious infection can lead to the death of a child. So let's think about it this way, for example, about measles. Many people ask, why vaccinate my child? Because if he goes through the infection, doesn't his immune system become stronger? So is it better for him to go through the infection? Normally, this is true for 95, maybe 99% of children. For 99% of children, it's true, but 1% can die from it. And the question is, can we accept this as long as we can protect those children so they don't die because of this? In my opinion, it's crucial that everyone vaccinates their children against measles. and their immune system can strengthen very well and very easily through much milder infections which are not dangerous and do not kill any child. So, in my opinion, we should let children and newborns get stronger to strengthen their immune system through harmless infections. Let me say they have them, and we all do, since everyone gets them occasionally. So those are infections that we can easily allow without any problem, and that helps strengthen a child's immune system. We must fight serious infections, which can be fatal for some children, as strongly as possible. Why do some people have mild forms of COVID while others end up in intensive care? There isn't a single answer to this. There are several causes that lead to this. One of the simplest causes, but that's probably not what we're referring to. There are times when there are people who clearly have a weakened immune system for various reasons. For example, they have a serious illness or are undergoing treatment for a serious illness. And in that case, it's clear. When the immune system is weakened, for example, someone undergoing chemotherapy because of cancer, their immune system is very low. It's normal for all the infections they get to be more severe. So this is a cause that's easy to understand and easy to notice right away. On the other hand, though, there are also people who are absolutely perfectly healthy, let's say, without any problems at all, and yet they still have very serious illnesses. Here I am. Here are a few causes that we can explain. For example, one of the simplest and well-known risk factors is being a man. Men generally have more severe infections, and this was very clear with COVID. Men had significantly more severe infections than women during COVID. Why is this? The explanation is very simple and very logical. That's the fact. Because genetically we are different and women have. So the difference between men and women is at the level of chromosomes. Chromosomes are They are the bodies in the cell nucleus where our DNA is found. Generally, we have 23 types of chromosomes which are the same in men and women. In addition to that, we have 2 types of chromosomes in which they are different. Women have 2 X chromosomes. Women, on the other hand, men have 1 X chromosome and 1 Y chromosome, and that also determines sex and so on. But what is very important to mention is that the X chromosome is a large chromosome, so it contains many genes and has a lot of immune genes. Among them is also one of the most important receptors for the virus. That causes the COVID infection, the severe acute respiratory syndrome, CoV-2 virus. It is recognized on immune cells. The white cells in our blood recognize it as a virus, and the immune system reacts through this receptor. So it's a molecule on the surface of immune cells that recognizes the virus. It says, this is a virus, and I need to defend myself. Well, women have twice as many receptors for this virus as men do, so they recognize the virus much more easily and can activate their immune system much more easily than men. And because of this, for example, women in general have had COVID. That doesn't mean there weren't women who had a very severe form of the disease, but overall, in the entire population, there were fewer women who had a severe form of the disease than men. That's one cause. The same thing can be explained by the way the immune system reacts to a viral infection. Basically, 90% of the patients who died from COVID did not die directly because of the virus, in the sense that the virus multiplied in their blood and they killed the person, right? So a lot of people died from COVID from an inadequate reaction of the immune system, which produced too much inflammation, too much activation of the immune system, which started to randomly attack its own organs as well. And of course, 95% of the people who had COVID had a mild or moderate case, so they didn't have any problems. But about 5% had a more severe form of the disease, and that's due to an inadequate reaction of the immune system. Here, what we discussed earlier about exposure also plays a role. Someone who lived more in nature and was exposed, for example, not only to nature, but also to certain infections, who caught mild infections from others. The immune system learned when it needs to defend itself and respond strongly to an infection, and when it needs to tolerate an infection. And to say, yes, it is an infection, but it doesn't need to react so severely that it leads to problems. Well, those people, on the other hand, who didn't have this exposure, this education of the immune system, their immune system reacts very strongly, inappropriately strong, to a relatively mild infection. Those people can have a very severe form of the disease. For example, so to speak, why is it necessary, after all, to maintain a balance in all our behavior and to change it when needed? For example, during COVID, people wore masks so we wouldn't infect each other, which was very normal and very appropriate for that time. For example, I sometimes see people still wearing masks in their cars while walking down the street, though it's rare. I still see someone wearing a mask thinking it's better not to get infected. That is not healthy right now, when there is no longer a serious infection circulating in the population. For us to isolate ourselves microbiologically from the rest of the population is inappropriate, because at that point, our immune system no longer knows how to react to a mild infection and reacts extremely strongly to a mild infection. That's not good. So we maintain, let's say, our balance, and when it's necessary to take action, we do it, but when it's not necessary, we should also give it up just as easily. So from this point of view, there are many factors that influence how our immune system reacts to an infection. And this determines, in the long run, how severe our infections become. Some things we can't change. For example, the fact that we have a certain genetic makeup, like having more or fewer receptors for a certain virus. I can't do anything, I can't change that, and there's nothing you can do. But that's how it is, so we have to live with it. But there are certain things we can do. Of course, we should have a balanced life so that our immune system reacts normally to an infection. We should have contact with the community so that our immune system gets proper education about the infections we encounter, and so on.
I mentioned the way we influence our immune system. How can diet, for example, directly influence the immune system?
Diet can influence the immune system, but we have to keep in mind that this happens over time. So doing it once doesn't have much effect, but a different diet over the long term can make a difference. How does this happen? Diet changes the immune system through two mechanisms. One of the mechanisms is the compounds in the diet that are contained in the food. We call them metabolites, so the different chemical substances that are balanced and that are used by the body, which also determines the energy intake. As long as the energy intake provided by our diet is equal to what we consume, it's perfect, because we maintain a certain weight. Of course, we have to be careful and try to make sure that energy intake is not continuously excessive, because at that point we gain a lot of weight, and this can negatively affect including the immune system. So that's one factor. The second factor through which, and diet also, a balanced diet brings us vitamins and certain minerals that are crucial for the proper functioning of the immune system. Now we have to think, It's very clear that the effects of diet on the immune system can be seen, especially when we have deficiencies in a certain component. The effect is much stronger, for example, if someone has a diet, for instance, that lacks vitamin D or zinc. Zinc, for example, is very important for the immune system. If there's a zinc deficiency, it's not good. But now we shouldn't think that suddenly we're not eating zinc, because zinc is found in a lot of foods. So when we eat a balanced diet, we eat vegetables, but we also eat meat and so on in proportion. We have everything we need. We don't necessarily have to take a lot more things. When someone has, on the other hand, a balanced and good diet and everything is okay, what does that diet bring? It's very hard to improve our immune system by swallowing 20 tablets of other vitamins a day. That doesn't really happen. So diet is crucial to provide everything you need, but once it gives you everything you need, it's much harder to influence the immune system, and it doesn't even need to. A second indirect way in which diet influences the immune system by modifying the type of microorganisms we have in our gut. And they, in turn, over time, can influence the immune system. But once again, the effects of diet on the immune system are crucial because they provide everything necessary for an adequate immune response. But when this is achieved, and in principle, it's someone's normal and balanced diet, it provides everything that's necessary. A normal, balanced, adequate diet provides what's needed for an appropriate response. So it's relatively easy to go from very good to bad, but it's much harder to go from very good to exceptional, because it's very hard to raise the bar when things are already very good. And it's not even necessary to struggle too much at this point.
What does it mean when they say that immunity comes from the gut?
It means, I think that's what they usually say. We must not forget that we interact with the outside world, basically, of course, also through the skin and so on. But the skin is an organ that protects us very well from interaction with the outside world. While, for example, interaction with the outside world happens mostly at the intestinal level, because there basically we eat food and so on. We even swallow microorganisms through food, because harmless microorganisms, let's say, are always present. Food is not sterile, and there's no reason for it to be sterile. So we come into contact with the outside world, especially at the intestinal level. This means that the organ with the most immune cells, with the most white blood cells in the body, is basically the intestine. Not so much the blood, but the intestine. And because of this, there is a continuous interaction between the immune system and the microorganisms that we have in the intestine, and the food and the water and all the liquids we encounter, and the intestinal system. So the immune system, which is at the intestinal level, and it is designed to protect us via the intestine. We absorb food but don't get infected, on one hand, and on the other hand, to tolerate the microorganisms that are in our intestine. So from this point of view, the intestine is the crucial immune organ in the body, together, of course, with other crucial immune organs: the bone marrow, the spleen, the lymph nodes, and so on.
Why, when there is this need to provide the body with zinc, called zinc, for example, why isn't it better to take immunity pills, to take supplements, or to do detoxes?
In my opinion, it's not necessary, because if we have a balanced diet in which we have all the necessary components, starting from carbohydrates, fats, the basic foods, vegetables, fruits, and so on, meat that provides iron, including zinc, and so on. Such a balanced diet gives us absolutely everything we need. It's much tastier, just between us, than taking tablets, in my opinion. Theoretically, someone can live very well by making an infusion every day with carbohydrates, proteins, fats, and so on. Just take some vitamin tablets and that's it. I think eating is much more enjoyable. And in addition to that, of course, there's the interaction at the intestinal level, including with the amount of food we consume. It also has some effects on certain intestinal hormones that are released and help maintain endocrine balance. From corporations, so the repair, as long as we can do it, sometimes simply there are certain components missing from the diet, for example, in certain geographic regions where iodine is absent from both the water and rocks. Because ultimately, if there is iodine in the Earth's crust and water flows through it, you drink it through the water and everything is okay. But there are certain regions poor in iodine which existed. Even in Romania, there were certain regions where there was an iodine deficiency, and at that time people had goiter. The thyroid didn't have enough. Iodine is crucial for the formation of thyroid hormones, and it would hypertrophy in an attempt to produce everything that's needed. At the moment when iodized salt was introduced, for example, or when iodine was added to bread, we no longer see what was seen 70, 80, 100 years ago, in which certain regions people had goiter, and it was, for example, if necessary, we have to do this, but we shouldn't exaggerate either. And that's not always the case. Moreover, it's even better. There always needs to be a certain balance. And our system is designed so that, in principle, we take everything we need and eliminate what is extra. On the other hand, if we provide too much, you can even get intoxicated with certain vitamins or with flowers, for example. You can get intoxicated from an excess of flowers. This is crucial, especially for teeth. Brushing them is important. But if, for example, you continuously take tablets with flowers and so on, it has a well-known effect on intelligence. It lowers your intelligence quotient by a few points. That doesn't mean we shouldn't brush our teeth anymore, so we need to be balanced in what we do. But excess of anything is not necessarily good.
Is it good or bad to take antibiotics often? What effect do they have on immunity?
So, if necessary, antibiotics are crucial, because if it's a bacterial infection that can kill people, like pneumonia, if we don't take antibiotics for pneumonia, the mortality rate is 30%. It's very simple. So the calculation is very simple. Do you want to have a 1 in 3 chance of dying or not? So you have to take antibiotics. So taking antibiotics when you need to is crucial. Unnecessary use of antibiotics, in the long run, they can have negative effects because, for example, they affect the beneficial microorganisms that we have in our intestines, for example. Indeed, at that moment, we can no longer process certain foods, we can no longer absorb certain products, and so on. So at the same time, we create resistance to antibiotics, and when we have a real infection, we can no longer treat it normally with the antibiotics we have. So we have to take antibiotics when we need to and not overuse them or take them when it's not necessary.
Is it true that your mental state can have an effect on your immune system?
Absolutely, yes. So stress, and when someone is very stressed or very upset or something like that, it has an immunosuppressive effect. So it definitely lowers the level of the immune system, and that person is more susceptible to long-term infections, probably even to cancer, although that's harder to study, but to infections, to cardiovascular diseases, for example, definitely yes.
You can be too clean. Why do children who play in the mud seem healthier?
So this goes back to the discussion we were having a few minutes ago. Definitely, you can be too clean. Especially for children, when they are young, it's really good for them to play outside, whether they're playing in the grass or in the sand. That's not a problem at all. On the contrary, at that moment, they come into contact with all kinds of substances from outside, which are absolutely harmless for them. They even come into contact with microorganisms that are on plants and so on, which are not infectious for humans. But their immune system learns then what the difference is between a serious infection and microorganisms that are absolutely harmless and pose no problems. And then their immune system knows how to react appropriately in times of crisis. And at that moment, it doesn't anymore. So definitely the incidence of allergies and asthma is lower. The immune response against infections is better and so on. So definitely, yes, a child kept indoors, isolated all the time, clean and washed every day, doesn't necessarily mean that at that moment they're not healthy, that they're very healthy. But as soon as they touch something, and that does happen, for example, children who don't go to kindergarten or anything like that, when they start school, in their first year at school, they get one infection after another. That doesn't mean their immune system isn't good. On the contrary, their system is just learning at that moment what it needs to do. But for that, they need time. For a year or two, they'll face many infections.
I'd like to ask you something since we're nearing the end. And if you can tell us in your field of research, what are the new things we can expect? If there's something happening or about to happen that makes you say that
It's worth telling.
A lot of things are happening. So people, how should I say, for example, during COVID, just to give the example of COVID, because that was the most prominent thing, let's say, both in the media and in people's attention and so on. If we can look at what happened during COVID from a scientific point of view, how incredibly fast vaccines were developed, antiviral drugs were developed, and immunomodulatory drugs were created to rebalance the immune system at such an incredible speed, which has never happened before in 3 to 4 years. We had the cause of the disease, we had medicines to treat the disease, we had vaccines to prevent the disease. This has never been achieved before in history. This can show what it means to get involved. Of course, suddenly so much money was invested in this disease because it was necessary. The entire scientific and economic power of the world focused on one disease and it was solved. We know more about COVID now than we know about the flu or about tuberculosis, which is truly unimaginable for a new disease, for example. The same thing is happening much more quietly and calmly with many diseases right now, including cancer, including cardiovascular diseases, and so on. Let's not forget the cancer mortality rate in the 1970s, which is 50 years ago. For a person's life, it's a lot, but for a society, 50 years is not much. For the history of mankind, it's not much. The cancer mortality rate was 90%. To cure 10% of cancers, well, right now we can cure more than 50%. So in 50 years, we have managed to practically cut the mortality rate in half. For example, from cancer. Infant mortality in diseases in developing countries, for example, in Africa or India or so on, has decreased in 20 or 30 years by more than 2 or 3 times. So people like to talk about what's bad on television. We can still improve many things, but if we look at how many things have been done well and how many things have improved during this time, it's still incredible considering the extremely short period. From the point of view of humanity, let's say it like this. Humanity as a species, we as a species, are about, let's say, around 300 to 350,000 years old, probably. But we're talking about what has happened in the last 50 years or in the last 20 years. So the speed at which discoveries are made, the speed at which new therapies are developed, the speed at which new things are done. And there are so many that they become almost commonplace. And because of that, nobody talks about them on television anymore. If it had happened, some of the discoveries we have every week now, if they had happened 100 years ago or 80 years ago, they would have been on television all the time. But Because they happen so often, these important discoveries become almost trivial and nobody cares anymore. And from that moment on, we only show the bad things that are still happening or what else is going on, and so on. And unfortunately, people believe or have the feeling that science or medicine can no longer keep up, or on the contrary. The level at which we make and these discoveries are made is so important that the discoveries have become commonplace. And that's what people don't understand anymore. And maybe that's what should be said more often.
Mihai, since you mentioned time, thank you very much for the time you gave me.
You're welcome. I'm glad we talked, and it was a pleasure for me as well.
And Ada, we'll see each other next time with the next guest. Goodbye.
Goodbye.